Most people don't question the world they wake up in, but not you. You saw something, felt something, a glitch, a gap, a whisper. Welcome to Quantum Cracks. Tonight, we open the file on the multiverse theory.
You've heard people talking about it, maybe even seen some crazy YouTube videos. But what actually is the multiverse theory? Is it all just science fiction? Or are there really other universes out there? In this video, we're going to look at where the theory comes from, what it means if it's true, and how close we are to finding evidence for it. The basic idea behind the multiverse is simple enough. Our universe contains not just everything that we can see, but everything that exists, right? Well, if that's the case, then surely there must be other stuff out there that we don't know about, right? Maybe there's more of the universe that we can see, but no, because we can see all the way to the edge of the observable universe, and beyond that lies more empty space. Or maybe there are other things happening that we can't detect, like dark matter or dark energy. They're causing our universe to expand faster than the speed of light, which would keep us from ever being able to see the edge of the universe. But no, we have lots of evidence for dark matter and dark energy, and we know that their effects are not strong enough to hide the edge of the universe from us. So it looks like our universe doesn't have any edge, which rules out both of these ideas. So the only possible solution is that there are other universes besides ours. Now, I know that sounds pretty wild, but let me give you a little background on where this idea came from. As I mentioned earlier, the theory arises naturally from cosmic inflation theory. You might remember that around 380,000 years after the Big Bang, the universe went through a period of exponential expansion known as inflation. The idea is that there was some kind of field called the inflaton field that decayed into normal matter. Radiation and dark energy in that decay released an enormous amount of energy that drove the rapid expansion of the early universe. Inflation solves a lot of problems with the Big Bang model, such as why the universe looks so smooth and featureless on large scales. But it introduces another problem, namely what happened to all the inflaton fields that didn't decay. Well, the answer is that it's still out there, but it's in regions of space far away from us that have been cut off from the rest of the universe by the rapid expansion of space. Since these regions are outside the observable universe, we can't see them, but theoretically they exist. This means that there are other parts of the universe that are essentially separate from ours, and they continue to inflate even today. These are sometimes called bubble universes since they expand into the surrounding vacuum like bubbles in a cup of coffee. Now, you might think that if there were other bubble universes out there, they would all be exactly the same as ours, because they all came from the same primordial soup. But they don't have to be. See, in any given region of space, the inflaton field has a random value. This is just a consequence of quantum mechanics, and this means that when the inflaton field decayed in our part of the universe, it decayed into a specific set of particles that created our universe with its particular physical laws. But in a different region, the inflaton field had a different value when it decayed. So it produced a different set of particles that created a different universe with different physical laws. So you can have bubble universes with different numbers of dimensions or different fundamental constants. For example, maybe in one of them, gravity works differently, or the strong nuclear force is weaker. Now, physicists haven't ruled out the possibility that our universe is the only one that is physically possible. But if it isn't, then there are many more bubble universes out there that have physical laws that simply are incompatible with life. And this is a problem for the multiverse, because if that's the case, then it seems unlikely that we would have evolved by chance into intelligent beings who can detect the presence of other universes. In fact, we wouldn't expect to see any evidence of the multiverse at all, which is one reason that physicists prefer a different version of the theory called eternal inflation. Eternal inflation says that the inflaton field doesn't have a definite value in any given region of space. Instead, it constantly fluctuates. And this means that new universes continue to spawn from the quantum fluctuations of the inflaton field even today. That means that there are bubble universes out there with different physical laws, but also universes that are identical to ours up to some point and then diverge in some way. There could be versions of you watching a slightly different version of this video in which you click the thumbs up button. And in another version, you decided to subscribe. And in yet another version, you left a comment saying, "You're wrong." And I was like, should I delete that? But eternal inflation isn't the only source of the multiverse. There's also quantum mechanics. One interpretation of quantum mechanics says that every time you make a decision, the universe splits into two. In one universe, you choose pizza, and in the other, you choose salad. Then every time you make another decision, each of those universes split again. This means that there are an infinite number of universes that are very similar to one another, but they diverge on every choice that you've ever made. This theory is called the many worlds interpretation of quantum mechanics, and it's highly controversial. Most physicists do not like it very much because they think that it makes the theory of quantum mechanics unnecessarily complicated. But this doesn't mean that it's wrong. And several physicists have pointed out that this type of branching multiverse can explain a few weird coincidences that we have noticed in our own universe. For example, it can explain the fine-tuning of physics. You know how the fundamental constants of nature seem to be perfectly tuned for life? If gravity were any weaker or any stronger, or if there were even just a small change in the mass of the electron or proton, then it seems unlikely that life could evolve. Some people take this as evidence that there's some kind of grand design to the universe, while others simply point out that there are probably trillions of Earth-like planets out there on which life has evolved independently. So it's not that surprising that we find ourselves perfectly adapted to our environment. But there is nothing in the Big Bang model or any other existing theory of physics that explains why our constants have the values that they do. However, the branching multiverse does provide a natural explanation. Basically, there are an infinite number of universes, and in some of them, the constants of nature have different values, but only in the ones that are suitable for life does life happen to evolve. And since we're part of that life, we obviously live in a universe where the constants are perfectly tuned for it. Déjà vu might also be explained by the multiverse. Déjà vu literally means already seen in French, when it's that feeling that you've already experienced whatever it is that you're currently experiencing. It's not a mystical or paranormal phenomenon, according to the multiverse theory. Instead, every time you make a decision, your universe splits. So there are other versions of you out there that have experienced what you're currently about to experience. And sometimes the brain gets confused and mixes them up. And finally, there's the issue of missing antimatter. As I mentioned earlier, the Big Bang model predicts that equal amounts of matter and antimatter should have been created in the early universe. But we don't see much antimatter out there. The entire universe, as far as we can tell, is made almost entirely of matter. This is another thing that the multiverse theory can explain. In some universes, the amount of matter and antimatter is the same, but in others, there's a slight imbalance. And it just happens that in the ones that are suitable for life, there's slightly more matter than antimatter. We just happen to live in one of those universes. So is there any evidence that any of this is true? Well, unfortunately, no. We can't test the predictions of the multiverse theory because we can't see beyond the horizon of the observable universe, and we can't interact with other bubble universes or other versions of ourselves. That doesn't mean that the theory is definitely wrong, though. It just means that it's currently untestable. It's also worth pointing out that while the multiverse is often portrayed in popular culture as a bunch of parallel universes stacked on top of each, they're like in the movie Everything Everywhere All at Once. That's not how it works. In fact, there's no reason to think that any two bubble universes overlap. They're just completely separate from each other. Finally, I want to say that I don't think that any of this stuff is particularly shocking. I mean, it's not like we believe in unicorns and magic, right? We accept the existence of invisible, intangible fields that govern the behavior of matter and energy. And these fields extend throughout all of space and time. And that's just as crazy as the multiverse theory. In fact, the only reason that we don't believe in the multiverse is that we haven't seen any evidence for it. But believing in the multiverse isn't irrational, and it's certainly no crazier than believing in a bunch of invisible fields. And if you really enjoyed my videos, please consider supporting me. Like and subscribe, and leave a comment below. And thanks for watching.